Hello everyone, I hope you are doing good. In the previous video, we learned about circular linked list. Before the project, before project we learned about circular linked list. I even solved some examples of single and link and double linked list. I hope you got all the basic concept of single and double linked list. We need the concept of linked list to learn stack that we are going to learn today in the later part. So I want that you should know the concept of linked list, at least the single and double linked list, because if you know single and double linked list, circular will be automatically understandable for you. So today we'll learn about stack. So this is just simple base code. So if you run this, you can see here in the site will be written there. Today we'll learn stack. Today we'll learn about stacks. So before going to the code, I want you to understand what stack means. That's why I'll show you with the help of an figure. So let's go to my photos and you can see that here I have drawn a figure. You can see that. Okay, now let me explain one by one what all this figure mean. First of all, this is stack. What is stack means? Stack means keeping a item one upon another. I hope you already heard about stack in, I think, in the library or anything, like keep the book and stack means keep one book in top of each other. So what is the best concept of stack is it works on the concept of LIFO. LIFO means last in first out, means whatever the item we are adding last, it will always be on the top. If you know about linked list, when we inserted something in the head, yeah, it works in that way, inserting in the head. So you can see that push item, when you push an item, means when you put an item, it goes in the above the top and behave as the top, because you know this will be the top because this is the last element added. And when we try to remove, you can see that when you try to remove the first one, that whatever is in the top will get removed first. Means it works on the concept of whatever is added newly, this will become as the new head. And when it is to be removed, it will remove the head first before going to the last. Means it will remove one by one, first this, then this, then this. Means it will go one by one to first this, then this, then this. It does not remove the one that was added at the first, at the beginning. Not, it removes the one that was added at the end. Means it will remove first the item that was added in the end. So this is the main concept of stack. See the figure once more, you'll understand that when we push an item, it enters in the head and behaves as the head of the stack. And when we remove first the head before going to the item that was first added. This is the item that was firstly added, and this is the one that is added at the end. So this will get removed first. And if you want to add any item, it will be added in top of this. It will be added in top of this item. So this is the main concept. You should know this about this word LIFO, because this works on the concept of LIFO. Means whatever is entered last will be first to be removed. So this is the main concept of stack. I hope you are getting this with the help of figure. So now let's go to the code. Let's go to VS Code. Okay, let's remove out this line. This line was just to say you what we are going to learn today. So our stack can be done by two ways. So let me write. Okay, let's write here. It can be done by two ways. First is we can do it with the help of, firstly it can be done with the help of an array. So we can do the, it can be done by array, and it can also be done with the help of linked list. So today in this video we'll be learning how to do with the help of an array, and in the later part we'll learn how to do about linked list. The concept is different, means the concept is same, but just the process is different. So let's start today with the help of an array. I'll say one by one every line of the code, and before the code, please see this figure. You need to understand this figure to get the concept. Let me say one more time. Whatever the item is added last will become as the head of this stack, and whenever it is to be removed, it will be removed first. Okay, let's go to the code. Now first of all we'll create a class. Let's create a class. Let's come to be down and create a class. We'll create a class named stack so that it becomes easy to understand. And we'll create some data members. First data members we'll create is top, because we wanted to know where this is. Because we want to know the condition of this item. This will become as the top first time when it is added. This will become as the top, and serially second time this, and the top will be increasing. And when we need to remove, we need to decrease the top. So that's why we'll add one item called top. We'll just write int top. So this is our first data member. Second, we'll add like whatever we want to do. First we want to push, so we'll just write push and this. and we want to even pop out. Pop out means just to remove some item that is inside the stack. So we'll add push pop, and there is one more we'll add. We want to see that if our stack is empty or not. So we'll just write is empty. So this is the things we'll do. Okay, we did not write here, we didn't mention the return type. So I'll just write it. For this I'll put it boolean. So just to push items, and for popping out I'll just try to print out whatever is to be popped. Okay, this is our basic code. These are all in the private, you can see that. Now we need to add something. Now we need, what should happen when we call all of this. Okay, let's go and add this in the public so that we can access it. The function should be in the public because we want to have access on this function, but the item means the data members, we want it to be private because we don't want that outside world should have access to this. Okay, that was it. And now we'll add one more constructor to this stack. Means we want that whenever a object is created of this stack, we want that our top should take the value of -1. Why we are taking -1? Let me come down to here and see. If we are taking before constructor, we want -1 because whenever we want the counting should start from 0, 0, 1. I mean this should be 0 and this should be 1, 2 and so on. So we want that before creation it should be -1, so that when we add something to it, it will come in the positive number and all will behave as positive. So we'll write that whenever a constructor is called, whenever a object of class stack is created, we want that the top should have the value of -1. That's it. And we know that if you want to push something, you need to add a value. We'll just write int x. That is it for our stack. So now what we need to do, we need to add all the functionality, what all of this should do. Okay, let's come down here. Okay, this is giving an error. I don't, okay, it's removed. Okay, now let's add all the functionality. First of all, we'll do about this push. What should happen in the push? So you know how to call a function after the class. You can first name the class stack. Before naming the class, you should name the return type. Sorry for that, you should know what is the return type. So what was the return type? Our return type was boolean, so we'll just call bool. Sorry for that, I'm really sorry guys. So we need to call the boolean and name of the class was stack, and we need to add this double colon and name the function that is to be called. So we'll just write push. We'll just write push, and we want a argument inside this function. So that was it. Now we need to add the functionality. What should happen? Before adding, we need to check the condition. If our top means if this is more than our array, we are doing with the help of an array. Okay, maybe I forgot to add an array. Okay, let's add an array here. Let's go to our public and add an array here. So we want that we should have an array. Let's write int my stack. And you know, this is the main problem of an array. Means we need to say what should be the what should the storage capacity, the maximum size that array can store. So that is the main problem. We'll just add 10. So this is the main drawback of array. So we'll use linked list in the next so that we can overcome this. You'll understand this why you are using this slowly by slowly. So we'll add a condition. If our top, the top that we added here is more than or equals to the the size is more than equal to the size, then it cannot be added. You know that if it is exceeding our array, we cannot add any member. This will give to an error. So we'll just try cout stack overflowed. So we'll just write stack overflowed, means there is more item that you cannot add any more in this array. So we'll write stack overflowed and we'll just return false. We'll just return false for this. Okay, what if this is top is less than 10? So if the top is less than 10, we'll write else we need to add. In the else we need to add. Now we need to add the member because our top is less than 10. Now we can add any member that we wanted to add. So now let's add this member. We'll just call my stack, that is the name of the array, and we'll put the item. We'll just write top. We are doing plus plus before the top because we want pre-increment. If post increment, it will be added first for -1, and we do not want to add it for -1. Why -1? Because you can see here, first of all, top is -1, and we cannot add any any value for -1 because we know that counting starts from 0. And we'll just put the item or the value of x that we took in this argument. So we'll just write x. So now you can see that now before it was top was -1, so for 0 the value of x will get inserted. Now we'll just try to print out what was inside this. We'll just print out x, and we'll return true for this. We'll return. So that was it for push. The push function will work easily. Now we'll check for the condition. If our top is greater than 0, greater than equal to maximum size. If it is not, then perform this. If it is yes, just print out, say that the stack is overflowed and we cannot add any more member. There is an error this, I don't know why. We need to check in the later part to find what this error is. Okay, it's a lot more error, so we need to know why this error is coming. Okay, let's run one more time. Okay, there is no error. In place of ENDL, I wrote just END. That's why this long error was coming. Just for a word, you can see that my whole terminal was full of errors. So be careful in C++. This is a lot of trouble in the later part. Now this is done for adding item. So we'll just write adding item. So this is done. Now there is one more thing we need to do. We need to remove item. So we'll just write removing item. Now for removing item, we name the function as pop. So we'll just call the pop, and it's a return type of int. So we'll write int, name of the class was stack, and this double colon and pop. And now we need to add the functionality. Before functionality, we need to check if our top is less than 0. I mean, if it is -1, I mean there is no any item in the stack, we cannot remove anything. So we'll write cout, and we'll just write stack underflow. Last time it was overflow, and opposite of overflow is underflow. ANDL. Okay, that was it. Now we need to return, so we'll just return 0. Okay, now if this is true, means there are some items inside the stack, what should be done? So we'll just write else. Okay, else, remove this line. We'll write int item or int x equals to my stack, and we'll just decrease the top. So we want that the element we are decreasing it because we want to pop out the last element that was added. So here you can see that when we come here, the value of top will increase. So in the push, the value of top is increasing. So in the pop, the value of top should decrease, so that we can know that which item is being removed. So that is the main concept, and we'll just return the value of x. So that was it. I hope you are getting this now. And now let's come down and see if it is empty or not, because we want to know that our stack should not be empty. Check for empty. Check for empty. Sorry. And now we'll call the function. We know that empty we are checking with help of boolean return type. So we'll write just boolean, and name of the class was stack, double colon, and is empty. So now we'll check that if our stack is empty, we'll return true and false. So we know that what is empty. Empty means the value of top is -1. You can see here, if you go back, whenever a stack is created, if we'll check that if our top is -1, then that means it is empty. If it is more than -1, means it's 0, 1, 2, means our top is full. So we can just return top less than 0. Put this in a brace. Now see, now it will check if top is less than 0. If for the first time is called, then top will be less than 0 because top is -1. But whenever we start adding item, top will be greater than 0 and this will give false. For the first time it will give true if it is empty, but if it is not empty it will give false, so our condition will be correct. Now that is it for adding all the functionality. Now we'll check is our function running correctly or not. Now let's go to our int main and let's call our we'll call our stack. So we'll call our stack, we'll just write stack and we'll name it as stack2. Okay, our stack is called with the name of stack. So now let's push some item. We'll just write stack dot push and we'll add some number like 1. I'll pause a little bit and the later part you can see that all will be added. Okay, now you can see that I added 4 numbers. Now we'll try to see what is good. We know that when we go to the push you can see that we even set to print it out also. So now if you call this, before calling let's write here one word. This is push. So we'll write cout. This is pushed item. Okay, this is pushed item, we'll write, and let's see what we get the result. Let's run this. So you can see that our item are pushed 1, 2, 3 and 4 one by one. Now we need to remove this. You know that now we need to remove one by one, and you know that I said in stack removing start from the last means now this is the current head. The last element entered is the first to be out. Now we want to remove one by one, so we'll just pop out. So we'll just write cout popping out. Now you can see that what are the elements that will be popped out. Okay, now we need to pop. Let's call the function one more time. Before calling the function we'll run in a loop so everything's get pop out. So we'll write while our stack is not equals to empty. Our stack is not equals to is empty. You already know what is empty is. We wrote a function. After writing I'll show it one more time. The function I'll show you one more time. So we'll write if it is true. If it is true, because you know that, let's see here, this will become true only when there are no items in the stack, top less than 0. Okay, well, if it is not true, until it is empty, we need to just keep popping out. So we'll just write cout and stack dot pop, and we'll just end the line endl. Okay, we're getting an error here, I don't know why. So let's see what is the error here. Identifier is empty is undefined. So why it is undefined? Let's go to our is empty. Okay, is empty is totally defined, and no operator matches this operand types. I don't know what the error is coming. We'll run, we may have some error and we'll check out what this error is. Okay, now let's run this and we'll see the error. There may come error, you can see all this black. So there are a lot of error. No name typed in the structure. So where the error is coming, we need to check one more time. So the error was just here. You can see that I added 2 times not equal wherever we want to just call the function. So you can see the error will be removed now. Okay, let's clear out all this mess from the right hand side and let's try to run this. Okay, you can see the pushed item 1 2 3 4, and while the popping you can see that it's popped from 4 3 2 1. So that is the main concept of stack. If you are not understanding, let me go one more time. Okay, we are doing with the help of an array. When we'll do with linked list, you'll understand this in a better way, and you'll understand in a practical way how it is being done. So in the array, it is little bit of like, because we need to say what is the maximum size it can do, and in the linked list you know that there is no any maximum, you can just keep on going. So let's start one by one. This tool I need no introduction, I think, till now. We named a class called stack, in which we added an integer type top, because we want to know that what is the last element, or the what is in the top of the stack. Then in the public we called our constructor of the, or before the constructor we initialize an array of size 10. Of size, you can size it anything, we sized it 10 because we do not want to add more numbers and we don't want memory wastage, so we wrote 10. And in the stack, we create a constructor. We initialize the value of top equal to -1, because we want that before anything is added we want the value of top should be -1. Then we add a 3 function to push, to pop, and to check if it is in empty. And in the push we wrote that if our top is greater than 10, means it is more than the size of an array, then we can't add any member, so we'll return false. But if our top is less than 10, means it is in the bounded area of an array, then in the top we'll just add the number or the value of x that we saw here. We'll add the value of x. So, and we'll just print out the value. We can do it with the help of display, but we print it out in the same line so that we don't need to introduce one more function. And for removing, we call the function pop, and we check if our top is less than 0. You know, top will be less than 0 when there are no items in the stack. So we'll just write stack underflow, because if there are no item, what is to be removed is undefined. Else, if there are some items, we need that the value of x should be starting from the top, means you know that value of top will increase while pushing, so we want to decrease the value from the top, decrease the value, put it inside x and just return x. That's it. And for empty we want to check that if our stack is empty or not. If our value of top is -1, it is empty, so we check that if our top value is less than 0, just return that it is empty. That is the main basic code. In the int main we just push the items here, and for the popping we check the is empty condition and we just popped up. So that is the main concept of stack. So when we'll do linked list, means stack in linked list, this will be more clear, because we'll use like how we use in single and double linked list, like head, delete, display. That will be in a better way. So I don't prefer using array because I don't feel good using array, but in the linked list it's more easy. And I know it may be a little bit tough because we're using pointer, we're wasting a lot of memory by initializing a new pointer every time, but the concept will be more clear using linked list. So that is for today. I hope you all learned something new and you learned about stack, the basic concept. We'll do one more lecture on stack using linked list, that you may understand a little bit more better. So that is it for today. Thank you for watching. See you in the next.